Now, so this is going to be the review for your test on Wednesday. So, now, guys, can I talk, please? Do you want to hit the lights, please? We're going to do the oxidation numbers. Hopefully, by the time we get rocking and rolling through this, a lot of this stuff will come back to you. This is what you're going to see, but I'm actually going to work on the whiteboard app, the whiteboard of this. So let's just go ahead and let's start from here. Now, if I'm in your way, just ask me to get out of the way, and I will do my best. I know that I'm not made of glass, so we just got to work on it. Okay. So oxidation numbers is always the exact same question. The first question is always, is it neutral or charged? This is neutral, so set it equal to what? Set it equal to 0. Now, on the last oxidation quiz that we took, a lot of you missed several of these, and I don't understand how you could have missed this. If this is set equal to 0, what do you have to put to the left of that 0? You have to put 0, because 0 can only be equal to 0 if there's only one thing there. And so, which means it is 0. I was getting all kind of crazy stuff for this. All kind of crazy stuff. Like for the one that was charged every 3+, I was getting 0, and I was getting 1+. Just weird, odd, strange, different answers. So, if it's by itself, if it's not charged, it is 0. Let's play pretend for just a second that that's not what it was. That's going to get it. Let's just pretend that it was Fe3+. What would the oxidation number of that be? It'd be 3+. Because if it's equal to 3+, we're not trying to make it equal to 0. We're trying to make it equal to 3+, not 0. Okay, you only zero it out when it is equal to 0. So it's got to be equal to 3+. All right, so moving on to the next one. We've got KNO3. Now, if you look back at the worksheet that you're working on, do you see how one of them is underlined? Which one is underlined? N. That is the one that you're actually going to have to give me the answer for. All right, that's the one you have to answer. So, this first question, neutral or charged? Set it equal to. Second question, is anything by itself? No. Remember, we've rearranged the question order. Is a metal present? Who is it? What group is potassium in? So it's a +1. Bring it down, +1. Next. Okay. All right, so we have fluorine. It's not present. The next question is oxygen. So oxygen is -2, -6. So there has to be a number that can go in right there. It's +5. So as you go up, what are you going to be dividing by? 1 or nothing. So the final answer is +5. We good with that? Okay, guys, I'm sorry I'm way over here and y'all's way, but it's the best I can do. Any questions? Okay. Next one. C2O4 2-. I'm going to see how far I can get. Can y'all see? Just want to see how far I can get before I get choked to death. Okay. So, this one's going to be set equal to what and why? Very good. Its charge is -2, so set it equal to -2. Come back on. Is that warm air? Okay. All right. So nothing's by itself, so we ignore that fact. Is a metal present? No, metal's not present. So then we go to fluorine. It's not there. Oxygen is there. So oxygen is -2. So we've got -8. Sorry, I don't know why I was going to write 6. So we've got something there. And so there has to be something that can be plugged in. +6. Now, if you wrote +6 down as your answer, would you be right or wrong? All answers must come from the top. 6 divided by 2 is +3. Now let me ask you something, a very analytical question. What's different about carbon's oxidation number in this problem as compared to carbon's charge on the periodic table? Carbon's in group 14, so it can be plus or minus 4. So, when it's a non-metal, does it have to carry its charge? No. Metals do. Non-metals don't. This is an example where its oxidation number is different from its charge. Okay? Alright. So that's all good and well. So then we've got SRSO3. So we're going to be searching 4s. That's the one that we have to find. Okay? What am I setting this thing equal to? 0. Okay? Is anything by itself? No. Is a metal present? Yes. Who is it? Strontium, Sr. So what is its charge? Okay? So we're going to get a +2 there, +2 here. Okay? There's no fluorine, so let's jump into oxygen. So we've got -2 for oxygen, -6, and so again, like I said, we've got an answer. We've got to get for right there. +4. Am I going to divide by anything? Nope. So again, that's its answer. Same question I asked the last problem. What is different between sulfur's oxidation number in this compound and sulfur's charge? Its charge is -2. Again, do non-metals have to have the same oxidation number and charge? No, but do metals? Yes, metals do. Okay? Alright, I'm going to do 2 more for you real quick. So this was a little different. UF6. What am I setting it equal to? Alright, still setting it equal to 0. No metal, right? Uranium is not a metal. It's one of those weird lanthanide things that we don't, or excuse me, actinides that we don't ever really talk about, but we're still going to treat it like we always do. So we're going to say, no, it's not a metal. Nothing's by itself. Is fluorine present? What is fluorine always? Always a -1. Okay? So, we have -6. What does that have to make uranium? +6 divided by 1. So uranium is going to be a +6. Okay, so this would be the 6th. Now, all right. Last one for me. I'm going to give you guys a chance to do 2 of them. Just for fun. Don't say it out loud. Please, please, please do not say it out loud. Just for fun, name that acid. Don't say it out loud. Don't say it out loud. First of all, is there a hydro in this thing? Why? Because there's an O. Okay? What polyatomic is this? 8 turns 2. So this is sulfuric acid. Okay? Just throwing that at you. Alright, now, so we're going to set it equal to 0. Is a metal present? No. Oxygen is -2, -8. Hydrogen, in this case, is a what? +1. Can hydrogen be something other than +1? Yes, when it's with who? A metal. And what does it turn into? -1. But here's the deal. If you'll do your metal first, that exception will take care of itself. I promise. I promise if you do the exception first, it will take care of itself. So hydrogen is a +1, +2. It's like I have to beat on this board to get it right. Be very careful here. What is it? +6. So there's my answer. +6. Is that a what? Okay. All right, you guys do the next 2 and see if you can figure it out on your own. And yes, that is a -1 power. Good. So the first one, what do you set it equal to? All right, so I guess you can't. You can't do it with your finger. That's interesting. -1. So, all right, so we've got to set equal to -1. What is oxygen? All right, so we've got -2, -6. What has to go on that blank? +5. So that's exactly what chlorine is. It is +5. Now, yes, sir. Yes, sir. I saw a hand. Yes. Okay, this next one, what am I setting it equal to? 0. Now, this is the one that I was waiting to get to because, like I told you, if you do the metals first, it takes care of the exceptions. So, is the metal present? Who is it? Calcium. What is calcium? +2. Bring down your +2. What has to go on that blank? -2. So when you go up, -2 divided by 2 is -1. Now, what's odd about that? Hydrogen's a -1. What have we learned it as? A +1. Why is it a -1? It's with a metal. If you will do your metals first, the exceptions take care of themselves. I promise. Yes, sir. You're right. right, it does say find calcium. So really, you don't have to do this from the answer. You're going to have them two points, right? But I wanted to show you that from this perspective. Okay? All right. Any questions on those? Now let's move on to the next set. This is molar mass and percent composition. Guys, this is the easiest thing you could possibly do. Now we're going to skip down to number 4 for a reason. 4 is just a little easier than everything else. Break my flash drive. Okay. All right. So BAF2. So whenever we do molar mass and percent compositions, we need to determine exactly how many elements are, how many atoms of each element are present. So when you do BA, how many bariums are there? 1, and how many Fs? Okay, so there's 1 BA and 2 Fs. Now, what do I multiply those numbers by? They're masses. You need the masses from the periodic table. How many decimal points do you round to? 2. Barium is 137.33 times 137.33, and fluorine is 19 even. Does anybody need a calculator? Anybody need one? You're going to need your calculators. If you don't need one, I got some out there in that box. Tonight, will you go out there? I'm going to tell you what, Haley, will you do me a favor since you're a little less locked in? Will you go out there and grab that calculator box just on my cart, please? Okay. So we know, obviously, it's 137.33. What is 19 times 2? Duh, 38. That was a stupid question. And what do I do to these numbers? Add them up. Tonight, you need one. Will you pass it back to her, please? Thank you. Plus, who else needs one? Anybody else need a calculator? So, what's your total mass? I'm telling you right now, if you do this problem and you leave it like that, will you earn full credit? You will have 1 point deducted from this. I'm just forewarning you, so don't complain if you have a point deducted, because what do you have to have? Very good. Grams per mole. Yes, I'm telling you it's that important. You have to have the unit. So those of you like Nick who don't like to put units on things, Nick, you don't do either. Okay? So you will lose points on this. Now, that is the answer for molar mass. So if the question is, what is the molar mass of this compound? That is it. Okay? That is your answer for molar mass. Now, we've got to do part 2. Part 2 is what is the percent composition. So I'm just going to throw this at you. I gave you a basic definition of percent, and what was it? Part over whole, exactly, because that's what a percent stands for. It's a part over a whole. What is the whole thing? 175.33. How many parts to this whole are there? 2 parts. Divide each part by its whole. So we're going to take both of these values and we're going to divide them by 175.33. Now, when your answers, you're going to get percentages. What do you give your percentage values in? Whole numbers. Okay? Now, when you do part over whole, is it going to give you the exact percentage in your calculator? There's 2 ways you can do it. What's one way in the calculator you can do it? Move the decimal 2 places to the right, or multiply times 100. Either way, honestly, it's a lot easier if you just move the decimal 2 places to the right. When you get your percentages, does it have to add up to 100? What did I tell you it could be? 99 or 101, right? That's just a fair for you. I'm not going to force you to make sure your rounding is perfect, because guys, I don't round perfect every time too. As long as you're within 99 to 101, you're okay. All right, anybody get percentages on these two? All right, so 78 and what? Now, I know basic math, and that is 100%. But if you did 21, you'd still be at 99. So you'd be okay. So as long as you're within that realm, you're good. Do you agree that these are too easy to mess up? Way too easy to mess up. I'm going to do one more just to make sure we're all on the same page, and I'm going to go back up to number 1. And it's, correct me if I'm wrong, FeNO33, correct? All right. Now, here's the reason I want to do this one. Because whenever you have parentheses and oxidation numbers and percent by mass or percent composition, what do you have to do? Very good. You have to distribute. Juwan, do me a favor. Will you shut that door for me so we're not bothering them? Thank you. All right. So when we do FE, we've got how many FEs? How many N's? And be careful, how many O's? It is not 6. Do not add the numbers. Let me tell you where you get messed up the most is when it's a 3 and a 2. I see 5 all the time because people don't think to add. 3 times 2 is 6, not 5. Okay? That's the one where people mess up the most. All right, iron is 55.85. 85. Nitrogen is 14.01, and oxygen is 16 even. What is 14.01 times 3? 42. And then 9 times 16? Okay. Add them all up. What'd you get? 241 point what? Very good. Grams per mole. That's our whole. We're going to divide it by each part. You guys agree that there's just a method to it? Nothing changes in terms of what you do step by step. Just the atoms, the mass changes. The steps are always the exact same. So many people get bogged down with the numbers in chemistry. If you just realize that it's very methodical, chemistry is so much easier. Because you can get really, really bogged down with, oh my gosh, where did that number come from? But do you understand where it came from? If you can answer that, you understand what people were. Or you understand why I did it a certain way. Percent for iron. Alright, nitrogen. And finally, thank you. And that obviously adds up to be 100%. Alright, so we good on all these. These aren't too terribly hard at all. Very good. Everybody good on that? Okay. Alright, we've got 40 minutes to work the rest of these problems that we're going to work on, but I'm going to kind of bounce around. So here's the interesting part. I didn't realize until after I already made the copies. The 10 that are on the front are the exact same 10 on the back. So if you want to work them on the back, there's a lot more room. That's where I would encourage. So it's the exact same problems. It's the same 10 on the front as it is on the back, and I didn't realize until after I made the copies of it. So what? Just like this. You work it out all on your own, and I'll grade your work. Alright, that's actually a good question. Notice how it says in number 1, it says 0.96 moles of KF to grams of KF. If you notice in 1 through 7, you would have never calculated the mass of KF. Here's what I've actually done to make the test go faster. The ones you have to do the percent composition for and the molar mass, I use those exact same compounds on these conversions. You already have the mass. So you don't have to recalculate all your masses. You've already got the masses. Now, let's pretend, for some reason, you mess up that red number at the bottom. And then question number 1 is, use that mass to convert to something else. You missed this one, right? But as long as you use that number in the right process, you can still earn credit for the bottom part. So it's not a double jeopardy kind of thing. I'm not going to mark this one and the other one wrong just because your mass is wrong. I want to know, can you follow the steps? Can you follow the directions? Can you go from this to this to this? The numbers are arbitrary. Numbers always change. I want to know, can you do the process? That's what I'm looking at. Okay? So, and again, I shortened it because when you find the mass, you use it for the rest of the test. You don't have to worry about it again. Okay? And I think there's 5 of each. I think there's 5 molar mass and 5 molar conversions. I think. Okay, so let's look at the first one. So we've got 0 point. Matter of fact, I can actually do it this way now. Oh, that's not any good. Do it on here. Perfect. Now, guess what the great news is? If we don't get finished with this, all the answers are in parentheses. So if you work it out and you want to know if you got it right or wrong, those things in parentheses are the final answers. Okay? So when you're calculating, if you're ahead of me, you'll know if you got it right or not. So that's why those are on top. Okay? So if we don't get this finished, it'll be a good idea for you to work these because you'll know if you got them right or wrong. So we're starting with 0.96 moles of, wow, that's a terrible K. Okay, yeah. And I'm going to go back to this, and I'm actually going to do something that I did in first period. It made sense to them. So I'm just going to rewrite it. Some of you are like, oh my gosh, stop talking, just get to the problems. But some people need this. What? That sound, I know. So, I know what you're thinking. Okay, what does all this mean? The bottom line is, if you're at the Dothan Airport, can you fly straight to New York City? You got to stop in Atlanta first. If you're at grams, can you go right into atoms or molecules? You cannot. You have to stop at the mole step first. Be very careful of that. Okay? Don't just jump straight across. You have to know where you're going and how you're going to get there. Yes, ma'am. Moles gets them one. If moles is with grams, it gets them one. But, all right, that's a great point. I'm going to come back to this. Yes, plus or minus 1. So like if you have to have 3 sig figs, if you have 2 or 4, you're good. If you have to have 2 sig figs, you can have 1 or 3. But if you have 4, it's 1 point off. So that's how AP does it. It's plus or minus 1 significant figure, so that's not anything to it. All right, so if moles is with grams, mole is a 1. If moles is with molecules, moles is a 1. But if molecules is with atoms, molecules gets a 1. Now, yes, very good. Does that help? Okay. Yes. sleeve shirts. Alright. Okay. Alright, so I'm at moles, and what am I going to? Am I going from one compound to the same compound? Yes. Okay, so we're okay. So I'm going from one compound to the same compound. Now, I don't want moles. Can I go from moles to grams in one step? Yes. If moles is on top and I don't want it, where does it go? It goes to the bottom, so we have moles of KF, and I'm going to go right into grams of KF. Now, this is where that last little thing I just showed you. If moles is with grams, what does moles get? 1, where does grams come from? Periodic table, I've already done that mass for you. It's 58.10 grams. Now, I want you to practice putting this in your calculator, just so you can practice the calculation. Every year, I have students who knock this out of the park and screw up when they do the calculator. And that's the part I don't want you to lose credit on. Some of that card. She's got one on her iPad. Haley. Sorry, not Haley, Mary. I was looking at you, and it just kind of. She had one on her iPad. She doesn't want to share. She's not free. Okay. Now, in terms of significant figures, how many sig figs do you have in your given? 2. So your answer must have 2. So when you multiply, now, when you multiply a number by a decimal, what should happen mathematically to your number? It should get smaller. Did it get smaller? What is it? 56. Now, is that 56 moles on your face? That'd be really weird. Okay. It is grams of what? If you don't put grams of KF, it is wrong. Completely wrong. Not points off. Completely wrong. Wrong. I don't know what it's 56 grams of. Okay? You have to, here, do you want another one, Caleb? Just add it to it. It's not hard. If you just put 56, yeah, if you put 56 grams, it's wrong. It's 56 grams of KF. It's kind of like if I told you your paycheck was 380. How pissed off would you be if I said cents after that? Exactly. You wouldn't be very happy at all, right? So you have to define your quantity. Okay. What if I said 380 in a currency? What if I said pesos? You wouldn't be very happy either, right? You've got to define U.S. dollar bills. Okay. Sorry. Okay. That's a great question. Hold on one second, Logan. Okay. All right. Bradley brought up a good point. I want to talk about this just in case you are to ever see this again. If I say a covalent bond, you agree that we call those things molecules, right? Here's the difference. If it's an ionic bond, it's called a formula unit. But it is so very rarely seen, we don't hardly mention it by name, but you see molecule all the time. So covalent is a molecule, ionic is a formula. You would just write formula unit. It acts identical to a molecule. Instead of writing molecule, you write formula unit. Metal. It's just a piece of metal, or an alloy. Okay, sir. Shh, shh, shh. All right, said it. No. Okay. So you're asking specifically, do you have to do the grams and moles? Yes. Okay. But do you have to do this and this? It helps. If you'll just commit to doing it, it makes things a lot easier. Okay. So Guys, real quick, what he just asked, and if you may want to hear this, okay, in the parentheses, you do have to do the green highlighter. You have to show grams, moles, atoms, molecules, okay? Now, I'm not going to mark it wrong if you don't have the yellow highlighter, the compounds. But if you'll just commit to doing it, what are you talking about? What are you talking about? I'm talking about the answer. The answer has to have the compound. So what I'm saying is, here's the big deal. If you don't put it, so you're seeing moles of KF, moles of KF go. If you just have grams, you're just going to put 56 grams. If you get in a habit of putting this here, you'll be in a habit of putting it there. Does that make a little bit of sense? It has to say that right there. If you leave that off, it's wrong. KF. It's just like I was telling him. If I said it's 300 and your paycheck is 380. 380 what? You have to be specific. So if I say currency, what currency? Dollar bills. You see what I'm saying? What compound? Okay. So let's move on to the next one. 1.98 grams of CaCl2. Now, dang it, I meant to, I guess I can. No, I want to go back. Now, let me ask you something real quick. This is really important, so please listen. Whenever we do molar masses, what are the units? Grams per mole, right? So you're telling me that there's that many grams in what? There are 58.10 grams in 1 mole of KF. That's how the units work. That's why the units make sense. That's why you can use it in that particular perspective. If I said you're driving 30 miles per hour, how long would it take you to go 30 miles? 1 hour. Or in 1 hour, how far could you go? 30 miles. It's a ratio. It's a relationship. So if I handed him this box and I said, that is 1 mole of calculators, how would you know how much that thing weighed? You put it on a scale and you figure it out, right? So if you have 1 mole of something, you use the masses. You figure out how much 1 mole would weigh. What? What word? Exactly. Exactly. So we have grams of Ca, ladies. Yep, do it by finding molar mass. All right. So I've got grams of CaCl2. Now I'm trying to convert to moles of CaCl2, which is a good thing. I'm staying within the same compound. But can you go from grams to moles in 1 step? Yes. Okay. If grams is on top, where does it have to go? It's got to go to the bottom. Grams of CaCl2 to moles of CaCl2. Now, and again, this goes back to that little statement I gave you a minute ago. If moles is with grams, what does moles get? Moles gets a 1. What does grams get? It gets the mass, right? So you got to figure out what the mass is. Good news on the test, you've already calculated it, and I've already got it for you. It's 110.98. Hang on, go ahead. You would have already done all those. You would already have 110.98 somewhere in the previous part of the test. That is a good. Okay, you would have already done that up here, molar mass and percent composition. So go back up, find that number, and pull it down. That's for time's sake. Nick. So, what cancels out? Okay, grams cancels, leaving you with grams of CaCl2. Sorry, my bad. No, wrong. My bad. Thank you. Moles of CaCl2. I want you to plug this in your calculator mathematically. What are you going to do? You're going to divide. In terms of significant figures, how many should you have? You should have 3. So when you do the answer in your calculator, did you get the Did you get 0.0178? If you didn't, you did something wrong. Now, hold on one second. Hold on. If you have 0.018, I'll accept that. That's two significant figures. So what I mean by answer choice is it's plus or minus one significant figure. If you have to have, hang on, if you have to have 3, plus or minus 1 means you can have 2 or 4, and you could still earn credit. Does that make sense? But if you put 0.017863, that's 5. You've gone one too many. I would take a point off of that. Question. Molecules and atoms. Molecules and atoms, yeah. Okay? Alright, so let's go on to the next one. As a matter of fact, I'm going to skip number 3, and I'm going to go to number 4. See, Nick? I was going to skip that one the whole time. I don't know. I'll go back and look at it. While y'all are working some, I'll look at it. So we've got 9.68 grams of P2O5. Now, here's the deal. I want to go from grams to what? No. I want to go from grams to molecules this time. You've got to read it very carefully. So, can I do that in one step? No, I've got to go through what step first? I got to go to my mole step. All right, so grams of P2O5 to moles of P2O5. Now, I know that grams of P2O5 is going to do what? Unit-wise. They're going to cancel out, leaving me with moles. I do not want moles, so I need to get rid of them. So I'm going to go from moles of P2O5 to cules of P2O5. Now, whenever moles and grams are together, who gets a 1? Moles gets a 1. Whenever molecules and moles are together, who gets a 1? Moles. What does molecules get? Now, I need somebody's help on the mass of this one. The mass I calculated is wrong. I actually Googled it, and Google is wrong. It's 1 something, 140 something. That's it. 141 point what? 94. That's the only one I need help on. Now, I want you to practice this on your calculator because I need to make sure that everyone knows how to get Avogadro's number into the calculator and get a right answer out of it. Make sure you plug this one in, please. Yes, 6.02 second EE 23. No, do not put E twice. Yeah, and don't put a 10. That'll get you off by 1 decimal point. Yes, ma'am. Bring it to me, please. Since you got one of those strange calculators. I have no idea. Oh, yeah, it is. It's right there. Did everybody get this right? Everybody make sure you get it right. I'm just gonna clear it all the way out. How do you clear the whole entire thing? Because sometimes these calculators just get too excessively complicated. You just do 6102, hit, nope, just do that. All right, so let's move on. Let's go to number 5. So this time, notice what we're going from and to. Molecules to grams of water. Okay? So I've got 1.69 times 10 to the 24th joules of H2O. Now, I don't want joules, so it's got to go on the bottom. But before I get to grams, what do I have to get it to? Got to get it to moles first. So I've got moles of water. And then from moles of water, what can I go into? I can go into grams of water. Now, grams of water is the only one I've asked you to memorize. What is it? 18.02. That's the only one I've asked you to memorize. And again, the reason I'm doing this, make sure you can put this in your calculator. Now with Avogadro's number being on bottom, you just have to do it a little bit differently. And the answer you should get is 50.6 grams. Again, please practice this in your calculator. I think you can all do the setup. I'm okay with that. Your calculator is what's going to get you. Sometimes it's just better to go back to a basic calculator. Do 1.69 EE24 divided by 6.04. Just the EE button. Alright, does everybody got this? Any calculator issues? Is the answer to the parentheses wrong? The parentheses may be wrong. Yes. What's wrong? Now, I want to go down, and I want to work, let's see, let's do number 8. So, notice something different about number 8. What are we going from and to? We're going from grams of SF6 to what? Atoms of F. Not SF6. We're going to F. This is exactly what we did on Friday. This is what we did on Friday. Okay? Alright. So, I've got 38.0 grams of SF6. Now, here's the deal. We all agree that grams of SF6 have to go on bottom, correct? We know that. We don't want it. We got to get rid of it. Now, before I ever go anywhere out of Dothan, where do I have to go? I've got to go to my moles first, right? So I got to get to moles of SF6. If I ever am outside of moles, I got to go through moles. Now, do you agree that grams of SF6 is going to cancel? Do I want moles of SF6? I know I don't want it. I don't know where I'm going next, but where do I have to put moles of SF6? I have no clue where I'm going, but I got to get that there. I know that for a fact. Alright, so I have moles of SF6. Now, what is the only way to connect SF6 to F? Molecules. If you know a molecule, do you know the atom ratio to it? Yes. So I got to get to molecules first. So I'm going to go to joules of SF6. Now, I don't know where I'm going, but if I want to cancel it off, I got to get it down here. Alright, so I've got moles of SF6 canceled. I've got molecules of SF6 canceled. So if I have a molecule of SF6, do I know how many F's are in that molecule? Yes. So I can now go to atoms of F. What's wrong? We did this Friday. We were like 6 problems. Okay. Now, everything works the same way. The mass of SF6, somebody if you got it. Thank you. What did you say? 146.06. If grams and moles are together, what does mole get? 1. If moles and molecules are together, what does mole get? 1. And molecules gets Avogadro's number. Now, this is the one that's different, is this step right here. We've got to figure out how to deal with this. Am I one person? I have 1 brain, 2 eyes, 2 arms, 10 fingers, 20 phalanges, right? In 1 SF6, in 1 SF6, how many F's? There are 6. So that's how you do it. Multiply it out and you're done. That's really going to hurt you in the next few chapters. Keeping it individual instead of doing it all together as a big group. Alright, so 38 times Avogadro's number times 6 divided by 146.06. And your answer should be 9.40 times 10 to the 23rd. See if you get that answer. That's a good question. What would you label that? What is the only thing left that hasn't canceled? Atoms of F. That's why if you get in the habit of putting the formula in the compound or in the parentheses, it solves that issue. You know what to put. Everybody good? Okay. We've got a few minutes left. I want you to do number 10 by yourself. Do number 10 right by yourself. I will tell you the molar mass. All right, last thing. Here's something I want to point out. Shh. If you look at this, guys, please stop. Do you agree that I know where I'm starting and I know where I'm going? In this particular problem, now, again, I get it. You wouldn't know how to have it set up for 3 steps, but the deal is you know where you're starting. You're starting at grams of dinitrogen pentoxide, and you're going to atoms of N. So you can know how to work it forwards. You can know how to work it backwards. But let's work it backwards. So if you're starting at atoms of N, well, if I have N, I need to get to N2O5. Well, if I know atoms of N, what do I need to go to? I need to go to molecules. So cules of N2O5. Well, if I don't want cules and it's on the bottom, where does it have to go? It's got to go on the top. So cules of N2O5. And what is the only way I can get from molecules to grams? Moles. So I need moles. Moles of N2O5. So do you agree? Do you see how I just worked it backwards? So if you know how to work it forwards, you should be able to know how to work it backwards. Now, I know that there, 6.02 times 10 to the 23rd. Now, again, I keep bringing this point up just to make an emphasis. If you see atoms and molecules together, molecules does not get Avogadro's number. Don't make that mistake. What does molecules get? A 1 and how many N's? 2. So then you'll just run those numbers and you should have gotten a final answer of 3.22 times 10 to the 22nd. We are good to go. All right.